Good afternoon, students. Today let me learn about the topic batteries. Batteries are indispensable in the modern electronic world. For example, lithium ion batteries are used in cell phones. Cell phones are using that battery, lithium ion battery. Tri-cell in flashlight. Flashlight we are using the batteries. Everybody know the batteries. Okay. So that tri-cell used in flashlight. These batteries are used as a source of direct current at a constant voltage. What is the purpose we will use that batteries means it is a source of direct current DC at a constant voltage. Batteries are classified into two types. One is primary battery, another type is secondary battery. Primary batteries means it is a non-rechargeable battery. Secondary battery is rechargeable battery. We will discuss primary batteries. First one, Lagrange cell. In a Lagrange cell, anode is a zinc container. Cathode, graphite rod in a contact with manganese oxide. See here, zinc. It is a anode. Carbon, cathode. Anode, zinc container is anode. Graphite rod in contact with the manganese oxide, MnO2. Electrolyte, ammonium chloride and zinc chloride in water. We are using the electrolyte, ammonium chloride and zinc chloride in water. EMF of the cell, EMF, electromotive force of the cell is 1.5 volt. So then we want to write the cell reaction. Okay, listen ma, batteries means anode is there, cathode is there, electrolyte. Okay, anode, cathode, electrolyte. In Lagrange cell, anode is zinc container. Cathode, graphite rod in contact with the manganese dioxide. Electrolyte is ammonium chloride and zinc chloride in water. So EMF of the cell is voltage 1.5 volt. So cell reaction, oxidation at anode. So oxidation means it lost electron. Zinc lost 2 electron to form zinc 2 plus ion. Zinc is oxidized to zinc 2 plus ion. Reduction at cathode. Reduction means gain of electron. Ammonium ion using the electrolyte ammonium chloride. Ammonium chloride split into ammonium and chlorine. That ammonium ion gain 2 electron to form ammonia, NH3. The hydrogen gas is oxidized to water. This hydrogen gas oxidized to water by MnO2. So H2 plus MnO2 gives Mn2O3 plus H2O. So overall reaction. See the reactant zinc plus. In this 3 equation, see the reactant side and product side, common term should cancel. Okay. So here 2 electron is there. There 2 electron cancel. Here one hydrogen is there. There one hydrogen cancel. Then any common term is there? No. Now we can write the overall reaction. See there. Remaining you should write Zn is there. Zn. Okay, this is Zn. The next 2 NH4 plus. 2 NH4 plus. The next 2 MnO2. That's all reactant. Then product. Zn2 plus 2 NH3. Mn2O3 plus water. Ammonia produced at the cathode combines with zinc 2 plus to form a complex ion. this ammonium at the cathode, this ammonia combine with zinc 2 plus ion to form a complex. That complex is a tetramino syncate. Z10 NH3 4 aqueous. As the reaction proceeds, the concentration of NH4 plus will decrease, the aqueous ammonia will increase. NH4 plus ion decrease, ammonia formation is increased, NH3 formation is increased. So that ammonia will increase, which lead to decrease in the EMF of the cells. The EMF value will be decreased. Then second one is a mercury button cell. So mercury button cell also a primary battery. So it have anode, cathode and electrolyte. In mercury button cell, anode act as zinc amalgamated with mercury. Cathode, mercury oxide HGO, mercury oxide mixed with graphite. Electrolyte is paste of potassium hydroxide and zinc oxide. Here that oxidation occurs at anode. Here zinc is converted into zinc 2 plus. Here loss of electron, that is oxidation. Zinc lost 2 electron to form zinc 2 plus ion, ZnO. So reduction take place at cathode. So mercury gain 2 electron, mercurous oxide gain 2 electron to form mercury. HgO is converted into Hg. So overall reaction, see the first and second, oxidation and reduction, that overall reaction. So reactant side and product side common term should cancel. OH minus, OH minus. Then 2E is there, 2E. Then any other term? Water, H2O. Okay, remaining Zn plus HgO gives ZnO plus Hg, mercury. Okay, Zn zinc plus HgO, mercurous oxide gives ZnO, zinc oxide plus mercury. So EMF, electromotive force, 1.35 volt. What is the use of mercury button cell? Mercury button cell is used in pacemakers, electronic watches and cameras. So this cell is used in, this is a mercury button cell. This mercury button cell used in pacemakers, electronic watches, cameras. It has higher capacity and longer life. It is higher capacity and longer life. Okay. So next let me learn about the secondary batteries. Secondary batteries means rechargeable batteries. So secondary batteries, we have already learned that electrochemical reaction which take place in a galvanic cell may be reversed by applying potential slightly greater than the EMF generated by the cell. Okay, so already we studied in galvanic cell, reverse reaction also possible. So this reverse reaction possible in secondary batteries. That same principle used in secondary batteries to regenerate the original reactant. That only secondary batteries are rechargeable. That means regenerate the original reactant. So secondary battery example is lead storage battery. Lead storage battery. Here we are using the anode spongy lead. Cathode lead plate bearing BbO2, lead dioxide. oxide. Electrolyte is 38% by mass of sulfuric acid with density, sulfuric acid density is 1.2 gram per milliliter. Okay, so we know oxidation occurs at anode. So oxidation means loss of electron. Bb lead, it lost 2 electron to form Bb2 plus. Then that Bb2 plus ion combine with SO4, electrolyte is SO4, sulfate, that sulfate to form BbSO4, lead sulfate. Then reduction occurs at cathode, BbO2 plus it accept electron or gain of electron, BbO2 is converted into Bb2 plus. That Bb2 plus again combine with SO4, 2 minus ion to form BbSO4, lead sulfate. So overall reaction, how you will write the overall reaction? What are the common terms are there? Bb2 plus Bb2 plus Bb2 plus. The next 2 electron, 2 electron. Okay, the next, so BbS. Okay, the next BbO2. So again this Bb2 plus we can cut here. Okay, BbO2, 4H plus 2 SO4 2 minus, here on SO4 2 minus, there on SO4 2 minus, so 2 SO4 2 minus, so the product side is BbSO4 plus water. So BbSO4 how many molecules? Here one BbSO4, there one BbSO4, so 2 BbSO4 plus water. The EMF of the cell depends on the concentration of the sulfuric acid. EMF of the single cell is 2 volt. Single cell voltage is 2 volt. Usually 6 such cells are combined in series. So it produce 6 cells produce, each cell produce 2 volt. So usually 6 cells are combined, it produce 12 volt. The EMF of the cell depends on the concentration of the sulfuric acid. As the cell reaction uses SO4 2 minus ion, the concentration of sulfuric acid decreases. When the cell potential falls to about 1.8 volt, the cell has to be recharged. Okay, the EMF of the cell depends on concentration of the sulfuric acid, that SO4 2 minus ion, the concentration of sulfuric acid decrease. So the potential falls to 1.8 volt, the cell to be recharged. Next one, recharge of the cell. Potential greater than 2 voltage is applied across the electrode. The cell reaction take place during the discharge process or reversed. During recharge process, the role of anode and cathode is reversed and sulfuric acid is regenerated. Here regenerating the acid, sulfuric acid is regenerated. Okay, so anode and cathode process is reversed, sulfuric acid also regenerated. So oxidation occurs at cathode, but it is reversed. That means now that cathode is act as anode. That cathode is act as anode, so that lead sulfate is converted into lead oxide plus 2. Lead 2 plus ion is converted into lead 4 plus. It lost 2 electron. Oxidation take place. Then reduction occurs at anode, but generated means it is a reversed, so that anode is act as a cathode. Lead sulfate gain 2 electron, Bb2 plus ion gain 2 electron to form Bb lead. So that overall reaction BbSO4 lead sulfate plus water gives Bb plus BbO2 plus 4H plus 2SO4 2 minus. That common term is electrons. 2 electrons. Overall reaction is exactly the reverse of the redox reaction which take place while discharging. Okay, so here redox reaction is happened, both oxidation and reduction. Reverse of the redox reaction is possible in recharge of the cell. So recharge of the cell is used in automobiles, trains, inverters. Okay, next battery is lithium ion battery. Lithium ion battery anode is used as porous graphite. Porous means it having the holes, small holes is there. Porous graphite. Cathode transition metal oxide such as cobalt dioxide, COO2, that means cobalt dioxide. Electrolyte is lithium salt in organic solvent. At anode oxidation occurs. Oxidation means that metal is converted into metal ion. Lithium is converted into lithium. It lost 1 electron. Lithium lost 1 electron. So Li plus plus E minus. Cathode reduction is occurs. That lithium plus ion gain 1 electron to form lithium cobalt dioxide. Okay, LiCOO2. So overall reaction only cancel that electron. Li plus COO2 gives LiCOO2. So both the electrodes allow lithium plus ion to move in and out of their structures. Anode having the porous graphite. That porous graphite through that Li plus ions only move in and out of their structure. So during discharge of the Li plus ion produced at the anode move towards the cathode. Li plus ion moves towards the cathode through a non-aqueous electrolyte. When potential is greater than the EMF produced by the cell is applied across the electrode, the cell reaction is reversed. That means lithium plus ions move from cathode to anode. Okay, first it will move from anode to cathode. Lithium plus ion produced at the anode move towards cathode. Potential is greater than the EMF. Reverse reaction, cell reaction is reversed. Lithium plus ion move from cathode to anode, where they become impeded on the porous graphite electrode. This is known as intercalation. Okay, intercalation means so lithium move towards the cathode, anode, from the anode to cathode. Potential is greater than the EMF produced by the cell. Lithium ions move from cathode to anode. This lithium ion battery is used in cellular phone, laptop, computer, digital cameras. Okay. So next let me learn about fuel cell. The galvanic cell in which the energy of combustion of fuels is directly converted into electrical energy. Combustion means burning. Burning of fuels it will directly convert it into electrical energy. That is called fuel cell. It produces the electrical energy. So this fuel cell requires continuous supply of reactant to keep functioning. So the general representation of that fuel cell is first that fuel, next electrode. So fuel is anode, electrode, then middle electrolyte is there. Then again electrode, oxidant. So let me learn about the hydrogen oxygen fuel cell. Okay. So hydrogen acts as fuel and oxygen as an oxidant. So electrolyte is aqueous potassium hydroxide, temperature maintained 200 degrees Celsius and 20 to 40 atmospheric pressure. Porous graphite electrode containing nickel and nickel oxide, it is served as a inert electrode. So graphite electrode containing Ni, nickel and nickel oxide. This nickel and nickel oxide is a inert electrode. Okay, hydrogen oxygen fuel cell. In this fuel cell, hydrogen acts as fuel. Oxygen is a oxidant. Electrolyte potassium hydroxide. Hydrogen and oxygen gases are bubbled through the anode and cathode respectively. Okay, they are passing the hydrogen and oxygen gases through the anode and cathode. Hydrogen passing to anode, oxygen is passed in cathode. Oxidation occurs at anode. Hydrogen is converted into water. Okay, it lost 4 electrons. So reduction occurs at cathode. That oxygen gain 4 electron to form 4 hydroxide ion. Overall reaction is hydrogen plus oxygen gives water. See here, oxidation occurs at anode. That hydrogen is converted into hydrogen ion. That means water H2O. It lost 4 electron. Cathode oxygen gain 4 electron to form hydroxide and OH minus ion. Okay. So the overall reaction is H2 plus I2 gives H2O. So here hydrogen combustion reaction with oxygen. Here combustion, overall reaction is a combustion reaction. Hydrogen combustion means burning with the oxygen. They do not react directly. The oxidation and reduction take place separately at the anode and cathode. See the diagram. Anode reaction and cathode reaction do not react directly. The oxidation and reduction take place separately at the anode and cathode. So example, H2O2 fuel cell, propane oxygen fuel cell, methane and oxygen fuel cell. Next let me learn about corrosion. So corrosion, that means rusting of iron. Okay. Have you ever noticed a green film formed on copper and brass vessel? In both, the metal is oxidized by oxygen in presence of moisture. The metal is oxidized, iron is oxidized by oxygen in presence of moisture. This redox process which causes the deterioration of the metal is called corrosion. Redox process, that means oxidation and reduction cause the deterioration of the metal, rusting of iron. So that is called corrosion. As the corrosion, iron cause damages to our building, bridges, etc. Rusting of iron is an electrochemical process. Electrochemical mechanism of corrosion. The formation of rust requires both oxygen and water. The formation of rust, that means reaction with oxygen and water, moisture. So, it is an electrochemical redox process. It requires anode and cathode in different places of the ion. The ion surface and the droplet of water on the surface form a tiny galvanic cell. The ion surface and the droplets of water form a tiny galvanic cell. The region enclosed by water is exposed to low amount of oxygen and it acts as an anode. The remaining area has a amount of oxygen. It acts as a cathode. Okay. So low amount of oxygen is act as anode. High amount of oxygen act as cathode. Based on oxygen content, electrochemical cell is formed. So that means corrosion occurs at the anode. So their anode, low amount of oxygen is there. Then water also there in that region enclosed by the water. So corrosion occurs in presence of moisture and oxygen. At anode, iron is converted into iron 2 plus oxidation. E0, that means standard potential, is 0.44 volt. The electrons move through the ion metal from the anode to the cathode area, where oxygen dissolved in water is reduced in water. At cathode, reduction is possible. Oxygen gain electron to form water. O2 plus 4H plus 4 electron will give to form water. In this equation, overall equation, that 4 electron. So that overall reaction is Fe plus O2 plus 4H plus gives Fe2 plus 2H2O. E0 standard potential is 0.44 minus 0.4 plus 0.44 plus 1.23. So overall E0 standard potential is 1.67 volt. The positive EMF value indicate that the reaction is spontaneous. The positive value indicate that the reaction is spontaneous. Fe2 plus ion further oxidized to Fe3 plus ion. So further reaction with the oxygen to form rust, that Fe2 plus further that is converted into Fe3 plus. So that oxygen to form the rust. So other metals such as aluminum, copper and silver also undergo corrosion. But it is slower than the iron. Form the rust is very fast comparing to aluminum, copper and silver. Aluminum is oxidized to Al3 plus. Al3 plus reacts with oxygen in air, forms protective coating of Al2O3. The coating acts as a protective film for the inner surface. So further corrosion is prevented. How to protect the metals from corrosion? Protection of metal from corrosion. So first point, coating metal surface by paint. Okay. So by coating iron rod or iron sheet, by coating by paint. So second method is galvanizing. Galvanizing means by coating with another metal such as zinc. Zinc is a stronger oxidizing agent than iron and hence it can more easily corroded than iron. Instead of iron, the zinc is oxidized. Iron will not corrode, but coating with zinc. Zinc is oxidized. Then third method is a cathodic protection. Cathodic protection means magnesium or zinc, which is corroded more easily than iron, can be used as a sacrificial anode, and the iron material act as a cathode. So iron protected, but magnesium and zinc is corroded. Cathodic protection means magnesium and zinc is act as a cathode. Is corroded, magnesium and zinc only corrode because that coating outside is magnesium or zinc. So iron is protected, but magnesium and zinc is corroded. Okay, so the next one, passivation. The metal treated with the zinc strong oxidizing agent such as concentrated nitric acid. As a result, protective oxide layer is formed on the surface of the metal. Any metal treated with nitric acid, combined with nitric acid, that nitric acid form a oxide layer. That oxide layer protect the metal. Next one is a alloy formation. The oxidation tendency of iron can be reduced by forming alloy with other more anodic metals. Example, alloy means mixing of two or more metals. So stainless steel is an alloy. It is an alloy of iron and chromium. Two metals, iron and chromium, mixing to form stainless steel. Next, let me learn electrochemical series. Standard single electrode potential are measured using standard hydrogen electrode. Standard hydrogen electrode is used to measure single electrode potential. The standard aqueous electrode potential at 298 Kelvin for various metal to metal ion electrodes are arranged in the decreasing order of the standard reduction potential values. That series is called the electrochemical series. Okay. See the diagrams here. Top to bottom, the metals or ions are stronger reducing agent. These metals are strong oxidizing agent. Lithium plus is a more oxidizing agent comparing Mg2 plus ion. The greater the E0 value, greater the tendency accept an electron. E0 value, E0 means standard potential. Okay, so standard potential value is here. That standard potential E0 value is greater, the tendency to accept an electron. Accept electron means it is undergo reduction reaction. So higher the E0 value, lesser the tendency to undergo corrosion. So that E0 value higher, it is less tendency to corrode. Okay, so electrochemical series, standard single electrode potential are measured using standard hydrogen electrode. The standard temperature is 298 Kelvin. So metal and metal ion electrodes are arranged in the decreasing order of the standard reduction potential. Standard reduction potential E0 is measure of the oxidation tendency of the species. The greater the E0 value, greater the tendency to accept electron. So greater the tendency to accept electron, it undergoes reduction reaction. So higher the E0 value, lesser the tendency to undergo corrosion.